Welcome back. Over the next few lessons, you'll learn about a new data structure called the linked list. So in this lesson, you'll learn what a linked list is, how to visualize it, how we traverse a linked list, and let's evaluate a linked list compared to other data structures that we know about. A linked list is a data structure. It's a linear data structure. Unlike the other data structures that you've looked at so far, a linked list is made of elements called nodes. Each node is in two parts. It stores an item of data, but it also has a pointer which tells us where the next node is. We could visualize a linked list node looking something like this: a piece of data with a pointer attached to it. By pointer, I simply mean a numerical address, an integer, which tells you the location of the next node in the list. The pointers join the data nodes together. So we start at the first piece of data. The pointer is a number. We go to that data location of that number and find a new piece of data and a pointer to the next node. So we have a series of nodes joined together to make a long list. If we create a linked list, the computer only remembers the location of the first node. It knows when it's looking for the list, it remembers the location of the first node in the list. Then it can visit all the other nodes by following the chain of links. It's interesting that the nodes don't actually have to be right next to each other in computer memory. They can be anywhere in the computer's memory. As long as there's a link, the computer can find the next node in the chain. We could show this in a 2D array. So here you can see I've got 6 numbered data locations, numbered from 0 through to 5. And each data location has got a piece of data and a pointer to the next location. So the computer would start at the header of the list. That would be node 0, and that's got A in it. And then follow the pointer to location 1, which has got B in it. Follow the pointer to location C, and so on. So if we traversed this array, we would end up with the values A, B, C, D, E, F. A points to B, B points to C, and so on. However, if the pointers were different, we would be visiting the nodes in a different order. For example, this list begins at node 0 with the value A, but the pointer is to location 4. So let's follow that pointer. Location 4 has got E in it, and the pointer is 2. So that points us to node 2, which has C in it. C is pointing to location 3, which has D in it. D is pointing to location 1, which has B in it, and B is pointing to location 5, which has the value F, and the pointer there is null, and by null we mean we've reached the end of the list. There is no further pointer. So this list is the list A, E, C, D, B, F. We don't just count down the array, we follow the number value of the pointer. And all linked lists work like this. So here's a test for you to see if you can get the hang of it. Imagine that the first node in the list is location 3. Now follow the pointers and get a bit of paper and do this. Write down the values in order as you visit them. So that should be quite quick to do. Follow the pointer starting at location 3 and I'll show you the answer in a second or two. If you don't think you can do it quickly enough, pause the video. And here's the answer. You would traverse the list in this order: D, A, B, F, C, E, and E has a null pointer. That's the end of the list. We also sometimes visualize a linked list using arrows to indicate the pointer. Obviously there aren't really arrows inside the computer. These are number values that point to the next data location, but you'll often see it drawn like this. In fact, I googled linked list and this was one of the images that came up. So because a linked list is quite flexible and is made out of pointers, using the pointers you can do a lot of things with a linked list that you can't do with a stack or queue. You can add values to the end, insert them in the middle, change values with editing or deleting values. We can obviously traverse the list, which we've just seen because we've just done it, and you can actually also sort and search a linked list. So really with a linked list you're quite flexible. You can do all kinds of useful operations. So supposing we wanted to evaluate a linked list as a data structure, how does it compare to the others that we've learned? How does it compare to a stack or a queue? And in what way is it different from an ordinary array? Well, compared to a stack or queue, a linked list has got a lot more operations. You can do all these operations which we can't do with a stack or queue, but we can do them with a linked list. So it's a much more flexible and wide-ranging data structure in that respect. However, it takes more operations. We've got to follow the links to get through the linked list, and so it takes the computer longer to work with a linked list compared to a stack or queue. And what about an array? Well, a linked list in many ways is similar to an array, but it doesn't have any gaps in it because the pointers join you directly to the next item in the linked list, and it's more flexible because you can grow it and shrink it by adding and taking away pointers. But again, it's slower to use than a simple array because the only way the computer can get through a linked list is to follow the pointers. So it has to track through the entire list to get to a particular location in the list. And what about a Python list? Python's got a list data structure. Has that got anything to do with a linked list? Well, the answer is yes. That's how Python stores a list. It's a slightly more complicated version, but basically Python uses this pointer method to create its lists that you know how to use. So you should now know what a linked list is, and you should know how to visualize a linked list as a set of nodes with pointers between them. And you should know how to traverse a list by starting at the header and then following the pointers until you reach the end of the list. And you should be able to evaluate a list in comparison to an array, a stack, or a queue. The key to being a good programmer is to know the range of different options you've got and to choose the right one for each occasion. If you're my student, there's a linked list worksheet to test how much you remember about what we've just been doing. In the next presentation, I'll visualize different operations done on a linked list, such as adding and taking away data. So see you then. Bye for now.